Oh shoot, I'm supposed to make a video. Sorry I haven't been that active lately. I've been doing college-type things, saving democracy, but also recording content just for you. I did not forget you. So where was I? Oh right, I needed a speaker. I stumbled across this. Wait. Speaker. The next thing I needed to do was read data from a music file. Then I had to plug that data into a digital to analog converter, or DAC, to output an analog audio signal. The ESP32 had two built-in 8-bit DACs, however, they can't output enough current to drive it to the speaker, so before it's connected to the speaker, I needed to route it through an amplifier, which was... Look at this idiot, making things more complicated on herself. This was the amplifier circuit that I was planning to make. But someone already did the job. Work smarter, not harder, kids. Forget most of what I said about amplifiers and ESP32 DACs. All you need to know is that this little breakout board is way better. It uses I2S, or inter-IC sound, meaning that the ESP32 can easily interface with it without having to worry about DACs or amplification, all taken care of. With the breakout board, I could just simply send audio data over from the ESP32, and the board would handle the rest. At least that's how I thought it would go. Alright, we are starting this with the demo. Am I gonna hear music or whatever? I'm scared. Like it's making noise, but what is this noise? Wouldn't you like to be woken up to the sound of this? Question. If I put a capacitor in the way of the speaker, will that reduce the noise? Yeah, no, it didn't really do anything. I'm so scared. I mean, that's better than before. There's some noticeable patterns and beats to it. Alright, here goes nothing. That was different. Oh. Alright, I forgot to change the sample rate, so let's do that. I finally got it to play something, however, there still were some problems. One, I was only playing snippets that I could store in memory. If I wanted full songs, then I would need more storage space, so I got an SD card reader and hooked it up. Two, the birthday card speaker wasn't gonna cut it. The audio quality just wasn't there, so I bought a better speaker. Then it was just a matter of playing the whole song instead of a brief snippet. Allow me to serenade you. So I know there's some clickiness in the audio. I fixed it. I don't know how I fixed it, but you know, it's fixed. So don't worry about it. So we're gonna be programming the remote button. I don't think it should be too hard. It was kind of hard. This remote button is supposed to be how I turn off the alarm so that I can have my alarm clock next to the bed, but to turn it off, I would be forced to get up. Genius, right? I simply hooked up a button to a transmitter, and when the button's pressed, it would transmit that it was on, and I could pick up that signal with the receiver. That is incorrect. Radio waves are more complicated than that. One very important thing is that you need to be able to encode your radio signals so that the receiver knows that what it's receiving isn't garbage. Because, our world is full of a lot of wireless signals, and there's a lot of radio frequencies being used, so, you want to be able to identify what signal you're listening to. It's kind of like if you're like at a party, right? A large party, and there's like a lot of conversations going on, and you're trying to figure out which one to tune into, but in the end, you just end up in a corner by yourself. So we needed a way to encode the signals, and that meant the return of an old friend, the Arduino. That wasn't the difficult part. The difficult part was getting the receiver and transmitter to actually work. I had bought some cheap 433 megahertz transmitters and receivers. They have worked for me before, but not in this case. I made an antenna out of wire to help with transmitting. Nothing. I bought pre-made antennas and soldered them on. Nada. I bought the gold standard of radios called NRF-24s. They're supposed to have all these features and reliability. Nope. They didn't work. I'm sure if I was a little bit more competent and had things like an oscilloscope or a proper power supply or knowledge, I probably would have been able to figure out what was wrong with them, but I didn't, and I was getting very frustrated. You ever just work on a circuit, get frustrated, so you decide to go to bed, but then in the middle of the night you wake up and realize that you could have fixed that circuit if you just had done that. So you get up, fix said circuit, but it made it worse, and then you're even more frustrated and more tired, and then you realize you could have solved all of your problems with a $12 Amazon purchase. My rescue came in the form of a pair of super heterodyne 433 megahertz transmitter and receiver. I don't know why these work so well, and others didn't, but that will be for another time, when I'm not traumatized by radio waves and electromagnetics. What matters is that they worked. Alright, let's try this again. Let me get my remote button turned on, so we'll be ready. Alarm is activated. Alright. And then... Yo! Okay. Nice. So yeah, the remote button works. The remote button wasn't the only button that was going to be used in this project. I also needed non-remote buttons. I had a lot of features that I wanted to implement, but I did not want to use a lot of buttons for each feature, so I took some inspiration from my old Nintendo DS. Yes, mainly the D-pad. The idea was that I could use the left and right buttons to select what value I wanted to edit, and I could use the up and down buttons for actually editing that value. I could also configure it so different combinations of buttons would trigger different events. I set up the buttons on a breadboard. Now you might be thinking like, wait a minute, that's not a D-pad, that's just a row of buttons. Well, the way the breadboard is set up, you kind of have to put the buttons in a row, because there's like no way to really put them in. Okay, yeah, I see. Look, I just want to say that I wasn't being that creative. Like, I didn't really think that like I should make the D-pad look like an actual D-pad. That was just a whole nother level of creativity that I did not have. And secondly, I just want to say that I put a lot of time into that edit, and it's beautiful in my opinion, and it's too late to change it now, and don't worry about it. Yeah, go watch the coding time lapse. So you might notice that everything looks like my outlook in life, darker. That's because I switched over to Visual Studio Code and used their platform.io extension to write code for microcontrollers. It's pretty nice. I will say that I was an early adopter of Visual Studio Code when it first came out because everyone was using Atom and Sublime Text, and I wanted to be different and quirky, but now everyone uses Visual Studio Code, and I don't feel different. And I realize that's now a personality flaw of mine. The main reason I transferred the code over to Visual Studio Code is because I needed to do some refactoring and housekeeping, and I wanted to have a proper file system instead of the weird Arduino IDE tab file system. I didn't record this process because refactoring is boring, but now my code is more organized, instead of just a bunch of random files scattered about. This was important because it was time for the bread and butter, the meat and potatoes, the rice and noodles, the thing that brings this whole dish together, the software architecture. Yeah, sorry, I was watching a lot of MasterChef recently. I designed this whole thing around something called a finite state machine, or at least I think it's called a finite state machine. And when I'm talking about state, I don't mean like the state of California. It's more like the current status of the program. My program would have 5 states: the clock state, the set clock state, the set alarm state, the set alarm sound state, and the alarm triggered state. The program would move between each state based on the button inputs and other events. Alright, let's walk through how this is supposed to work. Obviously, not everything is fully programmed, but at least the state machine is working. So we are in clock mode. This will display the time. Let's say I wanted to set the time, so this would represent the horizontal axis, the left and right buttons. I would just hold these down for 2 seconds, and then it would go to the set clock mode, and after a timeout, we'll go back to clock. This timeout will be based off of inactivity. If I want to set the alarm, I would hold the up and down buttons, or the vertical axis, down for 2 seconds, and it would go to set alarm. Pretty easy. And then if I want to set the alarm sound, I would hold down the left button for 2 seconds, and it will go to set alarm sound. And obviously they will have their interactivity programmed in very soon. Now it was time to put some functionality in these states. The clock state would display the clock, that's kind of obvious. In the set clock and set alarm states, you could change the time or alarm using the D-pad. The idea is you move a selector on the bottom with the left and right buttons, and you change the value with the up and down buttons. I'm pretty proud of that feature. I think it worked out pretty well. Okay, here we go. That is wrong. That is less wrong, but it also says 0 o'clock or 0:15 a.m., which it is not. There, that aligns both digits now. So now I can just select what section I want underlined. It looks a little disgusting, but this is what we're working with, so bear with me. If this works correctly, I should be able to press these 2 buttons down and be able to select which component, and that will be marked with the underline, but that's incorrect. Here is the problem. That less than sign is actually supposed to be greater than. Yep, that little thing made everything go wrong. Alright, so if I press these 2 down, it'll underline 11 and I can move around. And nice. Maybe I don't want to go. It's not as aesthetically pleasing as I thought it would be to have the underline extend past the numbers. I might change that, but that's a small fix. But yeah, it goes, you can switch the things. Now let's try decreasing. Oh, it's the little things. I haven't implemented the set alarm sound state yet, but I have some ideas. The alarm triggered state would just be flashy and play the alarm sound. Yep, I'm pretty annoyed. The alarm system was kind of set up as a state machine too. I had two alarms set up, the primary alarm and the emergency alarm that would be automatically set for 5 minutes later. You know, sometimes you have that situation where you forget to set your 4 or 5 alarms to wake yourself in the morning. Don't worry, the system takes care of it. You can only turn off all the alarms with the remote button, and I also made it so you can only snooze with the primary alarm, not the emergency alarm, so you know, we're having a lot of fallbacks here. And I got it to a point where, you know, I thought it was ready to try out, so all that was needed was a real-world test. Alright, so now we're ready for, I guess, our first real-world test. I am going to try to be woken up at, let's say like 8:15, yeah? Oops, 8:15 tomorrow morning. This could be a total disaster, or it could prove my genius. Alright, I guess I'll hopefully see you in the morning at 8:15. It is 8:15 a.m. Alright, I gotta turn it off. I gotta assemble this. Oh, what? It stopped. It turned off itself. That's not what I was hoping for. That's a bug. Okay. Look at her. Look, there's no room for you. I'm sorry. Yeah, turn around. You got this. Yep. There you go. Yep, stay there.